10, we have a city in the Pacific Northwest recorded its highest temperature at 72 degrees and its lowest temperature at 11 degrees Fahrenheit for a particular year. Use this information to find the upper and lower limits of the first class if you wish to construct a frequency distribution. Okay, so first of all, we find the range is going to be the high minus the low, and then we're going to divide that by the number of classes that we want. So that's going to give us 61 divided by 10. Plug that in your calculator. Notice whenever you're dividing by 10, you move the decimal over one place. So this is going to be 6.1. We round up to the next highest number so we can include everything. So that's going to give us a class width of 7 is what we're going to use. We start with the lowest number, which is 11 degrees. And we add the 7 to it to get to the bottom of the next class. So 11 plus 7 is 18. To get the top of the bottom class, we subtract 1 from, because you can't overlap. This has to be 17 for the first one. And again, you could keep adding 7 to get to the next level. 18 plus 7 is going to be 25. So that means this would be 24. Again, all we need to know is this first class here, it needs to go from 11 to 17. Yeah. Take it down one more. So, B. Determine whether the approximate shape of the distribution in the histogram is symmetric, uniform, left skewed, or right skewed, or none of these. So symmetric means it's balanced. It looks, same on both sides. Nope, that's not that. Uniform is a graph that would be straight across like that, rectangular in shape. Nope, it's not that. Left skewed means that you would have sort of outliers on the left side, so it would look like this. Nope, it's not that. Right skewed would have outliers to the right, which means it's kind of small out here and then the humps over here. This is the one. It's right skewed. Okay, so it's a right skew. There's a skew here. Now, again, don't look at the hump. That's to the left. It's where the outliers are, the lower values, and that would be to the right. Okay. Write the word or phrase that best completes each statement or answers the question. Let's see. The number of runs batted in that Sammy Sosa hit in the first 15 years of his Major League Baseball career are listed below. Find the mean and median number of runs batted in. Round the mean to the nearest whole number. Okay, so we can, with this, we can come to, where is my calculator? It is, it's disappeared. Open it up again. So let's go with this one. Make it a little bit bigger there. So what we're going to do is we are going to go to statistics. We're going to put in all this data under value 1. So we'll just start entering it in. 13, and it's got a frequency of 1. 70, 33, 25, 93, 70, 119, 100, another 119. Now you could have entered a 2 over here and just entered it once, but that's okay. You don't have to go with the frequencies. We just enter them a number of times. 138, 160, 108, and 103. So we've got all the data in there. Going to do a quick double check. 38, 160. Okay, that looks good. And then above this, 100, 119, 70, 93, 25, 33. Because if you made a mistake on any of these, you will get an incorrect answer. And this is a fill in the blank, so you've got to have the right. You go over to stats, and this is going to give us the values here. The median is going to be 103. So we can just write that down. The median, 103. And then the mean, we just keep going down. Oops, not that far. Sample means is 96.6, so 97, and you'll see population mean, same because that's what it thinks it is. So 97, we round it up. So that's all you got to do for this one. Okay, let's go for 13. Grade points are assigned as follows. A is 4, 3, 2, 1, so forth. Grades are weighted according to credit hours. If a student receives A in a 4 credit class, a D in a 2 credit class, B in a 3 credit class, C in a 3 credit class, what is a student's grade point average? So this is a weighted mean, and that's actually what this table is very good at doing. Statistics, I guess we'll leave it like this so we can kind of see what we're doing. I'm going to go back to data. I'm going to clear out these values. I come to the value and I hit clear, and yes, we will confirm. Oh, I guess I cancel, move over there, and then hit confirm. There, we got the data. So a student receives an A in a 4 credit class. So what that is they will get 4 points in a class that is weighted at 4 credits, right? D in a 2 credit class. A D is only worth 1, so they're getting 1 point. Let's come back here. 1 point, but it has 2 credits attached to it. So frequency is going to be the credits. So it's like, yeah. A B in a 3 credit class, a B is worth 3, so in this case we get 3 and we get 3 credits, weighted means, right? And a C in a 3 credit class, a C is worth 2 points, 2 grade points, and it's a 3 credit class. 4, a 2, a 3, a 3. What's their grade point average? So then that's what's the mean of this? This is a weighted mean. That's how grades are calculated. We come over to stats and we come down to mean. They're going to have a 2.75. Okay. Find the sample standard deviation. Again, we're just going to be able to enter all of these into the stats feature, and then it will calculate the standard deviation for us. So again, we go back to the data entry area. We're going to clear out our values we go there and we hit clear, and we have to confirm, and now it's cleared out. We just put in our data, 22, enter, 29, 21, 24, 27, 28, 25, and 36. So we've entered them all in. We do a quick double check. 36, 25, 28, 27, 24, 21, 29, and that top one should be 22. It is. And we come over here and we're going to look for the standard deviation, but be careful here. This first one, this is a population. That little symbol is a sigma, it's a Greek letter, that's for the population. They want the sample standard deviation, so Notice, well, that number 4.44 is not even here, but if we go down a little bit further, the sample standard deviation with the letter S, 4.75, 4.8, they rounded it. Okay, so we go with C. The mean score of a placement exam for entrance into a math class is 80. That's a mean, the standard deviation of 10. Use the empirical rule to find the percentage of scores that lie between 60 and 80. So the data is bell-shaped. So the mean is 80. So okay, empirical rule tells us it's based on the normal curve. We can go like that. Our mean is always in the middle, so there's 80. Standard deviation is 10. That means we can go up 10 for each standard deviation. So 80 plus 10 is 90. Go twice, they're at 100. And maybe go there. And then 10 more, so 110 would be 3 standard deviations out. You could also subtract off, so 80 minus 10 is going to be 70. 70 minus 10 is going to give you 60. And 60 minus 10 will give you 50. So we've got the 3 standard deviations above and below. That lie between 60 and 80. So that's from here to there. 60 is 2 standard deviations. 2 standard deviations below. So that would have been a -2. And 100, if we went from -2 to +2, the empirical rule would say that we have, between these two values, we would have 95%. However, we're only going from 60 to 80, so that is half of that amount, right? We've only got this half, we don't have the upper half. So we divide that in half. 95 divided by 2 is going to give us 47.5. A radio station claims that the amount of advertising per hour in broadcast time has an average of 15 minutes and a standard deviation equal to 1.1 minutes. You listen to the radio station for 1 hour at a randomly selected time and carefully observe that the amount of advertising time is equal to 9 minutes. 15 per hour. Okay. Calculate the z-score for this amount of advertising time. So remember that the z-score comes from this formula, x minus the mean divided by the standard deviation. So our mean is 15 minutes. Our standard deviation is 1.1, and our data value is what we observed, what we measured, 9 minutes. So we're going to get -6 divided by 1.1. Come back up here to the regular calculator. -6 divided by 1.1, and we get -5.45. Negative. It's below the mean. It's below the average. Hopefully you would have spotted this. It's below the average. Don't go, it's not just the value. Positive 5.45 is above the mean. It would have been more than 15 minutes, right? So you could almost just go through and cancel those out. It's got to be negative, and we see we're pretty far away from the mean. So I would say it's going to, without calculating, you could have just really gone with C. But just follow the formula and you'll be able to do that. And again, watch your signs as you're doing this. So the last one, we'll go ahead and do this. A student's score on the SAT-1 placement test for U.S. history is at the 90th percentile. What can you conclude about this student's test score? Well, 90th percentile means, here's the 90th. There's 100 percentiles. 100 is the highest, means you scored better than 100%. This means that the student scored better than 90%. better, higher. Maybe higher is a better word, more descriptive. Scored higher than 90% of test takers. Okay, and that is the summary, the solutions for exam 1. Thanks.